So one of the things we looked at was this. So if you wanted to graph x is greater than or equal to, let's say, -3. All right, so remember that's an inequality. That's inequality notation. Now when you graph, what is it that you're graphing? Do you remember what we discussed? You're graphing the solutions. So what numbers are bigger than or equal to -3? Huh? No, but give me some numbers that are bigger than or equal to -3 though. -2 is greater than or equal to -3. Okay, what else?
0, 1, 2, 3, 4, 5.
Sure, 1.7, 2.6, any real number bigger than or equal to -3. No one said -3, but is -3 a solution?
Yes.
Yes. Why is -3 a solution? Because it includes -3. Equal, there's an equal sign. So when you graph this, so here's 0, so -3 is on this side. And let's go ahead and use open and closed circles. Is this going to be an open or closed circle?
Close.
Closed circle, and I'm going which way? To the right. So you're going to shade in like this with an arrow. Okay, you have to use an arrow. All right, now we also looked at this. What if you had -5 is less than x? -5 is less than x. So you remember how we dealt with that? Remember, the mistake people are going to make is that they're going to put an, and is this going to be an open or closed circle?
Open.
Open. They're going to put an open circle -5, and they're going to draw the graph to the left because they see the symbol less than. But you got to be careful. Where's the variable x located? It's on the right side, correct? So when solving an inequality or when graphing the solution set, it's usually easier to deal with if the variable's on the left side. So the answer is not, don't do this, because that's not the right graph. Because if you look at this, what I've shaded, give me a number that's shaded right here. -3 is right here. 3 is right here. -7, right? So -7 is shaded. So is -5 less than -7? No, -5 is bigger than -7. So that's why this is not true. Okay, so we talked about the fact that when you do something like this and on your worksheet, you're going to see one where the variable's on the right side, rewrite it backwards. So how would you rewrite this? X is greater than what? -5. And so the graph should be this. That should be the graph. And then now give me a number that's shaded. 4. Is -5 less than 4? Yes. -5 is less than 4. Okay. All right, so we talked about that. Now, keep in mind that these right here, these are inequality notation. That's inequality notation. Okay, there's something also called interval notation. So let's talk about interval notation. All right, interval notation. Okay, so if I have this graph right here, and let's say my graph is 3, open circle going to the right. All right, so that's the graph here. And let's use the variable x. So in terms of inequality notation, how would you write this in terms of inequality notation if I take to use the variable x? What would you say? X is greater than 3. All right, so this is what you would say. X is greater than 3. That's inequality notation. Okay, interval notation would be this. That's where you write things as an interval. Okay, interval notation would be, all right, and all you basically do is just look at the graph. Okay, now you got to remember we talked about brackets and parentheses? Okay. So with open circle, you can use parentheses. With closed circle, you're going to use brackets. Okay. So the smallest number you see here, although you see a 3, but 3 is not included because of the open circle, but the smallest number you see is 3, right? And 3 to what? No, not 1. 1, 2, 3, 100.7, a million, 0.2. Say it again? Infinity. Thank you. So it's going from 3 to infinity. Okay, so when you put this in interval notation, the open circle corresponds to parentheses 3, comma, infinity. Okay, so this is going from 3 to what? Infinity. And you always read a graph from left to right, so from smallest to largest. And with infinity, negative infinity, you're always going to use parentheses. So this will always be parentheses with infinity, negative infinity. So that's interval notation. So interval notation is where you use brackets and parentheses. Okay, so number 2, suppose you had this. And number 2. All right, so this time you're going from, remember, you're reading graph from left to right. So when do I start shading this? When does it start shading? When I start at what number? 6. 6 to what? Infinity. So in terms of inequality notation, what are you going to write? Yes. Okay, in terms of interval notation, all right, you read a graph from left to right. So the closed circle corresponds to a what? Bracket. So you can say bracket, and then you're going to put what number? 6, and then a what? Comma, all the way to what? Infinity. And infinity, negative infinity, you're always going to use a parentheses. So there's your interval notation. All right, number 3. All right, number 3. Let's say you had 5, open circle going to the left this time. Okay, so remember, you always read a graph from left to right. So notice the first 2. The first 2, your arrow is pointing to the right, and number 3, arrow is pointing to the left. And you read a graph from left to right. So when you're pointing to the left, you're going towards what idea? Negative infinity. Okay. So in terms of inequality notation, you're going to say x is what? Less than 5. Okay. The inequality notation is easy. The interval notation, always go from left to right. Okay, so you go from left to right. So you have that arrow to deal with first. So that arrow is pointing towards what concept? Not infinity, but negative infinity. You're going to the left, you're going towards negative numbers, right? Negative 1 billion, negative 2 billion, and so on. So you're going to say parentheses, negative infinity, comma, all the way to what number? 5. Since that's an open circle, you're going to use parentheses. So that's interval notation. Number 4. All right, 4. All right, so let's suppose you had this one. Let's say negative 3, closed circle, pointing, and everything to the left is shaded. Okay, so inequality notation. X is what? Not greater than, less than or equal to negative 3, right? You're going to the left. Okay, interval notation. All right, so what would the interval notation be? parentheses, you gotta say parentheses first. Parentheses,
Negative.
negative infinity, comma,
Negative 3.
-3 with a,
Parentheses.
it's a closed circle,
A bracket.
bracket. Okay, so you see how some of you said parentheses with -3? It's a closed circle. Closed circle, you're always going to use what? Bracket. Open circle, you're going to use parentheses. Okay? All right, and then number 5, we had something like this. Remember we had that compound inequality? So -3 is less than or equal to x is less than, let's say, 6. All right, so what I want you to do is to graph this. So when you graph this, and this was from the previous class here, when you graph this, what does that look like?
Negative 3.
-3 with a, use open and closed circles.
Close.
Closed circle because of the equal sign, all the way to 6 with a
Open.
open circle because there is no equal sign. And I shade what? Everything in between. No arrows, right? Okay. So in terms of inequality notation, I'm sorry, that is inequality notation here. In terms of interval notation, where do you start?
Negative 3.
With a what?
Bracket.
Bracket. So bracket, -3, comma, all the way to what? 6 with a parentheses. So notice no arrow, no infinity to negative infinity this time because it's bounded between two numbers. All right, number 6. Okay, so number 6, let's suppose you have a graph this time. So let's suppose my graph is from 0 to 8, open, closed, and there's my graph. All right, using inequality notation this time. Inequality notation. Using the variable x. So all of my solutions between what two numbers? 0 and 8. Now how do you write this making it look just like the one we just did right here where we have -3 is less than or equal to x is less than 6. How would you write that? 0 is, go ahead,
8.
less than
Greater
x,
than. Yeah.
and x is less than or
Greater or
equal to 8. Okay, so that's how you write it. So 0 is less than, 0 is the smallest, right? So that's why you see 0 is less than. 0 is less than any x in here, and any x in here is less than or equal to what?
8.
8, that's what that says. So 0 is less than any x in here, and any x in here is less than or equal to 8. Okay, interval notation. What would the interval notation be? Parentheses, 0, comma, 8 with a bracket. All right, okay. All right, now, okay, so let's look at this idea now. Okay, so the directions this time are going to say solve each inequality. Just like you had in the test where it said solve each equation, you're finding the solutions. And with an inequality, all these inequalities that we just graphed had an infinite number of solutions. Now, not all inequalities will have an infinite number of solutions. There could be no solution as well. So you're going to see that at some point. But for the most part, you're going to have an infinite number of solutions. So for example, suppose I had number 1. We're going to start with an easy one. And you solve an inequality just like you did the equations. So if I had 2x is less than, let's say, 10, 2x is less than 10, I want to find out what numbers multiplied by 2 will always be less than 10. That's what I'm trying to find out. Okay? So if this was an equation, what would you have done? Divide by 2. And you would have gotten x to equal what? 5. That would have been your solution one solution if that was an equation, but it's not an equation, that's an inequality. But you do it the same way. So how to get the variable x by itself? Divide both sides by 2. And so therefore x is less than what? 5. So I found the solutions. All my solutions have to be less than what? 5. That's my solution. So when it says solve the inequality and I have the, I'm not sure how it's going to be listed on the worksheet, but let's suppose I have answer here for, let's suppose it says answer. You're going to say x is less than 5. That's what you're going to say. You're going to say x is less than 5. Now if it says graph, so you're graphing the solution set. So if you want to graph the solutions, what would you put? If this is 0, you're going to put what? 5, right? On the right, with open or closed circle. Going which way? To the left, with an arrow, something like that. Okay? All right, if I ask you to indicate the interval notation, what would you write? Say it again. Parentheses? Nope. Negative infinity. Comma? 5. Parentheses, because of the open circle. Okay. All right. Now, number 2, suppose you had 2x minus 1 is greater than or equal to, let's say, 6. 2x minus 1 is greater than or equal to 6. Two x minus 1 is greater than or equal to 6. What would you do? If this were the equation, add 1 to both sides. So I get 2x is greater than or equal to 7. And then how to get the variable x by itself? Divide both sides by 2. So x is greater than or equal to 7/2, right? Okay. So any number bigger than or equal to 7/2 is a solution. So if you're asked to graph this, now on the number line, let me just say this. So you're going to get, on your worksheet, you're going to get a number line that has numbers on it. So let's say this is 0, this is 1, this is 2. Let me put 0 here. 1, 2, 3, 4. All right, so let's suppose you had that. Where would you put 7/2?
Between 0 and 1.
Nope. 7/2 is not between 0 and 1. What is 7/2, people? 3.5. 7 divided by 2 is 3.5, right? So where would you put 7/2? Between 3 and 4, right in the middle, correct? So this right here is 7/2. Y'all agree?
Yeah.
Now, on 7/2, am I going to use an open or closed circle? Closed because of the equal sign. Going which way? To the right, because it says greater than. So there's your solution. I graphed the solution set. So the solution is any number between from 7/2 to infinity. All right, so that might be a situation where you're not going to get an integer here. It may be a fraction. So you need to remember. Some of you said at least one of you said between 0 and 1. So just make sure you understand that 7 divided by 2 is actually 3.5. Okay, so the interval notation. What's the interval notation? Bracket. 7/2, comma, infinity with a parentheses, right? Okay. All right, so that's interval notation. Okay, now let's look at this. Okay, so suppose you had this. It's not working. All right, suppose you had negative 2x is greater than 6. Negative 2x is greater than 6. All right, so again, if this was an equation, you would divide both sides by negative 2. All right, you would still divide by negative 2. But you got to be careful with inequalities. So let's look at this idea here. All right, so listen carefully to this. We all know that 4 is less than, let's say, 6, right? Y'all agree? Okay. Now remember, with an equation, and the same thing is true with an inequality, what you do to one side, you have to do to the other side. So if I multiply 4 by 2, I have positive 2 now, I have to do the same thing to 6, correct? And 2 times 4 is what? 8. 6 times 2 is 12, correct? So it's still a true statement that the left side is going to be less than the right side, okay? All right. Now, we're still dealing with 4 and 6. What if I multiplied 4 by negative 2? Then I have to do the same thing to 6. But this time, negative 2 times 4 is what? Negative 8. 6 times a negative 2 is a negative 12. But it's not a less than statement anymore. It's a what? Greater than. So it's a greater than statement. So the idea is this. When you multiply or divide an inequality by a negative number, you must reverse this inequality symbol. You must reverse the inequality symbol. So again, when you multiply and divide by a negative number, you need to reverse, change the direction of the inequality symbol. So I'm going to go back to number 3. When you go back to number 3, we had negative 2x is greater than 6. How to get the variable x by itself? All right, now remember I'm dividing by negative 2, right? So you got to remember that I've got to reverse this. So I'm going to circle this inequality symbol. You don't have to. But I'm going to circle this inequality symbol to remind me that I got to change the direction of that inequality symbol. So negative 2 divided by negative 2 is 1. 1 times x is x. But this time I got to say all of my solutions are what? Less than negative 3. All my solutions are less than negative 3. Okay? And so the graph, your solution, when you graph your solution set, so here's negative 3, open or close circle. Open going which way? To the left. So there's your solution. The interval notation, what would you write? Parentheses, negative infinity, because the arrow is pointing to the left, comma all the way to negative 3 with a parentheses. Number 4. All right, suppose you had negative x plus 2 is less than negative 3x minus 1. All right, now remember, when solving an equation, it does not matter which side you bring the variables on. The same thing is true for an inequality, but remember what we talked about on a previous page. If I can find it. This one right here. So remember, if the variable's on the right side, you need to be careful if the variable's on the right. So with an inequality, what some students prefer to do is just to bring the variables to the left-hand side, just to be on the safe side. But it doesn't matter which side you bring it on. So you tell me which side you want to bring the variables on. Left or the right?
Left.
The left? Okay, so I need to get rid of this negative 3x. So what are you going to do? Say it again? You're going to add 3x, right?
Yep.
And then combine like terms, what do you get? 2x plus 2 is less than negative 1. What's the next step? Subtract 2 from both sides. And combine like terms, I get 2x is less than negative 3. And then finally divide by 2. Do I need to switch an equality symbol? No. Only if you divide or multiply by a negative number. So all my solutions then would be any real number that's less than negative 3 halves. Okay, any real number that's less than negative 3 halves. Now, in terms of a graph, let's suppose I have the graph already numbered. Let's say this is 0, negative 1, negative 2, negative 3. Between what two integers is negative 3 halves located? Negative 1 and negative 2, because negative 3 halves is negative 1.5, correct? Negative 1.5. So here is right here. So this is negative 3 halves. Open or close circle? Going which way? To the left. So there's your graph. Interval notation, what would you write? Negative 3 halves with a parentheses. Okay. All right, number 5. Okay, suppose you had negative 2 times x minus 1 plus 3 is greater than or equal to 3 times x minus 2, let's say. All right. So what would you do? Okay, so if this was an equation, you would do the distributive property just like you did on test 1. So distributive property. So you would say negative 2x and then what? Plus 2 and then plus 3 is greater than or equal to. And then here, what would you get? 3x minus 6. All right. So on test 1, what would you have done? What would be the next step? Combine like terms. So I get negative 2x plus 5 is greater than or equal to 3x minus 6. All right. So again, I have variables on both sides, constants on both sides. It does not matter which side you bring things on. So what do you want to do? Huh? I can't hear you. You want to go to the right? Okay. All right, it's fine. If I want to bring the variables to the right, what would I need to do to both sides in terms of the variables? Add 2x to both sides. And so I get, when I combine like terms, I get 5 is greater than or equal to 5x minus 6. What's the next step? Add 6 to both sides. So I get 11 is greater than or equal to 5x. What's the next step? Divide both sides by 5. And so I get 11 fifths is greater than or equal to x. Okay. Now, let's say this is 0. Let's say this is 1, 2, 3. Okay. Use your calculator to determine what fraction 11/5 is as a decimal. What decimal 11/5 is as a 11/5 is equivalent to. So 11 divided by 5 is 2.2, right? So it's closer to 2. Y'all agree? So let's say this right here is 11/5. Right here. So on 11/5, is that open or closed circle? Closed. And I'm going which way? To the right, someone said? Is that correct? No. That's why, remember I told you, I said if with an inequality, if you're going to bring the variables to the right side, you need to be careful. Because this says that 11/5 is the largest number, right? So 11/5 has to be greater than any other x. So 11/5 is the largest. So if you bring the variables to the right, you got to rewrite this if you're going to make that mistake. So how would you rewrite this? You would say x is what? Less than or equal to 11/5. So that's why I said earlier, many students prefer with inequality to bring the variables to the left-hand side so they don't mess up like this. So it would be a closed circle, and you're going to shade everything that's to the left. All right, and then what would this be in interval notation? Parentheses, negative infinity, 11/5 with a bracket. Now, if you had brought the variables to the left, let's do the same problem up to a certain point, and this time let's bring the variables to the left. So right here, see this right here? Where we had negative 2x plus 5 is greater than or equal to 3x minus 6. Remember that one, that little part right here? And then I asked you which side you want to bring the variables on, and someone said bring it to the right. Okay, well let's bring it to the what? The left and see what happens. So this is number 5 another way. All right, so I would subtract 3x from both sides, and then combine like terms. I get negative 5x plus 5 is greater than or equal to a what? Negative 6. Then what? Subtract 5 from both sides, and so I get negative 5x is greater than or equal to a negative 11. All right, then what's the next step? All right, now remember, what must you do? You must reverse or change the direction or reverse the order of the inequality symbol. So therefore, x is what? Less than or equal to. Now remember, some of you got to remember that a negative divided by negative is a positive. So you must say 11/5. And that's what this was right here. Okay? All right. So just remember about the dividing by negative coefficient. You got to change the direction of the inequality symbol. All right. Okay, now you remember on your test you had something like this. Solve 2/3 x is equal to, let's say, 9, and you had to show that step. So what step did you have to show me on that test? Multiply by the reciprocal. So some of you would have said, I'm going to multiply both sides by what fraction? 3/2, right? Okay, so some of you would have said this. Others of you would have said this. So instead of multiplying by the reciprocal, what was the other thing you could do? Divide by the coefficient. So you divide both sides by 2/3. Correct? All right. So this right here, 3/2 times 2/3 is what number? 1. 1 times x is x. And then over here you reduce first. Oops, you can't reduce, right? Okay. So that's going to be 27 over what? 2. 9 times 3 is 27. 1 times 2 is 2. And the same thing here. 2/3 divided by 2/3 is 1. And some of you tried using your calculator and you kind of messed up on this on the test. So you just got to remember that this right here means the same thing as, say, 9/1 times what? 3/2, which gives you 27/2. So the same thing applies with any inequality. So in your worksheet and on my math lab, you may get something that looks like this. So this is going to be number 6. So let's say you want to solve negative 3/2 x is greater than or equal to, let's say 9. Let's say negative 9. So negative 3/2 x is greater than or equal to negative 9. All right, so how to get the variable x by itself?
Divide by negative.
Okay, so divide by negative 3/2, or you can multiply by the reciprocal. What's the reciprocal of negative 3/2? Negative 2/3. Not positive 2/3, but a what? Negative 2/3. Okay, doesn't matter what you do. So you could say, now you got to be careful. You could say negative 2/3 times negative 2/3, just like this. Okay, or you could do like just like we did right here. You could say divide by negative 3/2, divide by negative 3/2. Doesn't matter what you show me. But you got to remember right here, though, a negative 2/3 times a negative 3/2 is what number? 1. 1 times x is x. All right, and be careful. So notice I did multiply by what? Negative number. So what must I do that is greater than or equal to? Yeah, so reverse it. Change the direction of it. So it's going to be x is what? Less than or equal to. All right, so whenever you multiply or divide, in both sides of an inequality by a negative number, you have to change the direction of the inequality symbol. So you may want to circle the inequality symbol to remember to change the direction. Now this time I can reduce. So 3 into 3 is 1. 3 into the negative 9 is a negative 3. So what's a negative 3 times a negative 2? Positive 6. So all your solutions will be less than or equal to 6. Over here, negative 3/2 divided by negative 3/2 is 1. Now remember I did divide by negative number, correct? So I'm going to circle this to remind me to change the direction of it. So x is going to have to be what? Less than or equal to, and then I just figure out what this is right here, what this division is. So first of all, a negative divided by negative is a positive. So I have 9/1 times the reciprocal of 3/2, which is what? 2/3. So 3 into 3 is 1. 3 into 9 is 3. 3 times 2 is 6. All right. So either way, you get the same solution set. All right. Okay, so let's see. So in worksheet 9.7 part A, looks like this. So the first part, when you get it, so I'm giving you interval notation. See this interval notation? And you're asked to graph it. So notice the numbers on the number line. And I want you to use open or closed circles. And then you put it in inequality notation. And remember, I want you to use what variable when you put it in inequality notation? X. Okay, there's a front page. Don't forget the back. The back is what we did last class period. So you're given inequality notation here. You want to graph it, and you put interval notation. Okay. Now don't forget about these right here. So some of you are going to put a closed circle in 3, and you're going to shade to the left, which you know is not true, because that says that 3 is the smallest solution, not the largest. So you got to be careful with 9 and 10. So that's part A. Part B looks like this. All right, so part B, That's what we just did. So you got to get the variable x by itself, or in this case, the y. Doesn't matter what variable. So you see right here, notice I'm dividing by what kind of number here? Negative, negative, and then we did one like this. All right, so that's the front page. The back page, what we did last class period, and also we did one at the beginning of this class period. So these are what kind of inequalities? What do we call them? Compound. All right, so are there going to be any arrows on these? No. Okay. So that's part B. Okay. All right, and then we're going to, okay. Part C, remember this one right here that we just did? We did one like this. You can divide both sides by, or multiply by the reciprocal, divide both sides by 2/3, correct? Okay, we did one like this. We did one like this. Remember that one? Add 5 to both sides, divide by 2. We did one where you had to use distributive property. Change the back. We did things like this. See them? Okay. All right, now notice though, you see where it says show work? Show the work. Okay, do the steps. No, there's nothing here that says show work on 1, 2, and 3. But if it says show work, you got to do what? Show the work. All right, so like number 4, number 6, and number 8. Okay? All right, any questions with those 3? Okay. All right, so that's going to be on your next test, so I do need for you to work on those. It's not difficult. If you know how to solve equations, you can do these. Just remember, if you divide and multiply by a negative number, an inequality by a negative number, you have to reverse the inequality symbol. Okay? All right, so let me go ahead and give you those. Okay, so when you do set notation, it's going to look like this. I'm going to put set notation right here. All right, so listen to the words. So when you write a set, you're going to use braces. So it's going to look like this. So there's your open brace. Okay? And I'm using the variable x here. So if this was a variable y, you would use a variable y. So you would say this. You would say the set of x's, such that this vertical segment right here means such that. The set of x's such that, and all you do is write this inequality symbol right here. So such that x is what? Less than -3/2, and then close brace. That's set notation. So the set of x's such that, and then whatever your solution is, such that x is what? Less than -3/2. Okay? Over here, your set notation, you would say the set of, now what's the variable? X. Now in that worksheet, you have a variable y, you have an inequality with a variable y, so you use the variable y, not x, but y. So, but in this case, it's x. You say the set of x's, and then what would you say? Such that, and then x is less than or equal to 11/5, and then you close brace. Okay, number 6. So number 6 is did we do a number 6? Oh yeah, it's right here. Okay, number 6. Right here, so you say set notation. So it will be the set of x such that x is less than or equal to 6. Okay, so that's set notation. All right, so my math lab, they're gonna tell you to write set notation. Now when you do my math lab, it's gonna look like this though. So it will already have this part. It'll look like this, and it'll have a blank right here. So you'd have to put your cursor in the blank, and then in the blank, you would just say what in this case? x is less than or equal to 6. All right, so you already have most of the parts to it. You just got to put the inequality notation right here. So that's the way it looks on my math lab. Okay? All right, so any questions on part C, how the set notation looks? All right. Now, so the next, we're not done, but the next class period, we're going to finish 9.7. This is 9.7. We're going to do some word problems with inequalities. So we're basically done with this kind of stuff, except we're going to come back and look at a couple of word problems, and then I'm going to assign my math lab for 9.7. So you really can't do 9.7 yet, because on my math lab, there are a couple of word problems with inequalities. But just keep in mind, when you do my math lab, starting Tuesday, set notation means this. Okay, now let's go back to 9.4, the word problems we're looking at. So take out the sheet that you had last class period from 9.4. Take that out. All right, so the problem says that the room numbers of two adjacent classrooms are two consecutive even integers. And it says that their sum is 654, and you want to find the classroom numbers. Now, some of you could probably guess right away what those two numbers are, but you got to show some work. All right, so just give me the answer. You're going to be upset because I'm not going to give you full credit, if any. You have to show what I want. So when you get the worksheet for this, let me just kind of show you what that's going to look like. So if you look at this one on the worksheet, it says find three consecutive even integers whose sum is 72. So in that first box, remember we talked about represent the unknowns? All right, so there are how many integers that you're looking at? 3. So we're going to call them first integer, second integer, third integer. And then you got to represent each of those integers. Okay? Then remember the next thing you did, once you represent the unknown, what was the next thing we talked about? Setting up the equation. Then what was the next thing we talked about? Solve the equation, and then you answer the question in a sentence, right? Okay, so notice how this looks when you're dealing with integer word problems. So in this case right here, in number 32, how many integers am I looking at? 2. So when you talk about representing the unknowns, you're looking at the first integer and second integer, right? Okay. Now, what kind of integers are they? Consecutive even, okay? And so how would you represent that first integer? X, okay, good. So if my first integer is x, then the next even integer would be represented as what? X plus 2. And if this was consecutive odd, and my first one's x, how would my second one be represented? Oh, come on. You did the same thing last time. You did the same thing last time. I'm going to put x plus 1 in your forehead. X plus 2, right? How many times are you going to say that, girl? X plus 2. X plus 2.
But I thought it was like, don't you have to add one to make it odd?
Okay, you tell me if my first odd integer, listen, listen. If my first odd integer is 5, you're telling me 5 plus 1 is another odd number?
No.
5 plus what? 2. Okay. All right. And I bet you, I'm joking here, but I bet you're going to do the same thing in a little while. All right. So regardless of whether it's odd or even, it's always going to be x plus what? 2. I don't know how many times you're going to say this. All right. Now, so that's my unknowns. Now we got to represent we got to set up the equation. So how would you set up that equation? So you're gonna, it says there's sum, so sum means to do what? Add them. So set up the equation. So you can say x plus 2 equal 654. Yes, good. All right, so there's your equation. Then what's the next thing you got to do? Solve the equation so you can combine like terms. So you're going to get 2x plus 2 equal, Okay, then what? Subtract 2 from both sides. So 2x equal, then divide both sides by 2. So what is x? 326, is that correct? Don't trust me. You gotta trust that calculator. 326, is that correct? It looks correct. 26 times 2 is 52, right? And then 3 times 2 is 6. Okay. All right, now answer the question. What are you trying to find? No, you're not trying to find x. What are you trying to find? You're trying to find the classroom numbers. So the classroom numbers are 326 and 328. 326 and 328. Remember, once you find x, you know this one now, that's 326, right? You know this one now, that's 320 what? 8. So you're going to say the classroom numbers are 326 and 328. So now, in that box where it says answer the question, don't just put 326, 328. You'll be upset. You guys say the classroom numbers are what? 326 and 328. All right, answer the question. Answer the question. All right, 34. All right, 34. So the code to unlock a student's combination lock happens to be 3 consecutive odd integers whose sum is 51. All right, so represent the unknowns. So this time you're going to say first integer, second integer, and third integer. All right, so we're going to ask our friend. Tell me what those tell me what those 3 things would be. Okay, so this one's going to be what? This is going to be
X plus 2.
and there's going to be oh no.
Yeah, I didn't answer that one because I didn't know it.
X plus 4. You keep adding 2, right? So in other words, it's easy to figure this thing out, guys, if we're dealing with odd, right? So my first one, let's say, is 11. Then how do I get the next one? I add what? 2. How do I get the third one? I add what? 4. I add 4 to get the third one. Because 11 plus 4 is what? 15. So x plus 2, x plus 4. If there was a fourth one, you would say x plus what? 6. And whether it's even or odd, it would still be the same expressions. X plus 2, x plus 4, x plus 6. All right. So it is difficult to, because when you think odd, you want to add an odd number. But you got to remember your x was already odd to begin with. An odd number plus 2 is always going to be an odd number. An even number plus 2 is always going to be an even number. All right, so it's easy to I can understand why you do that, but it is
something with X plus 1 yesterday and it just threw me off. So I got it now. I wrote it down. I put stars by it.
All right. Okay, so then how would you set up the equation? Okay, and then solve the equation. Yep, so it's 3x plus 6 equal 51. Next up. All right. 3x equal 45. Divide both sides by 3. So x equal 15, right? Okay. Now remember, I made these up right here, so I'm taking these out. So we found x. That means that this is 15, this is 17, and this is 19. So so make sure you answer the question. So the question was find the integers. So the integers. So the student's combination log, something like that. You could say the integers are, because it did say find the integers. The integers are what?
15, 17, 19.
Or you could say the combination log is, the combination is what? 15, 17, 19, right? Doesn't matter how you write it. Just don't put 15, 17, 19. Say something like the integers are. The combination is. Okay? All right. Then let's look at number 16. Go number 16. Okay, number 16. Okay, so in 16 it says that a plumber gave an estimate for the renovation of a kitchen. Her hourly pay is $27 an hour, and the parts will cost $80. If the total estimate is $404, about how many hours does she expect this job to take? That's the question. All right, so a plumber gave an estimate, and the estimate is $404. The plumber charges how much per hour? $27, and then the plumbing parts, that's an additional $80, right?
Yeah.
And the question is, how many hours does she expect this job to take? So what are you going to let x equal?
27.
No. Let x equal what?
The hours.
The number of hours expected to take, right? So let x equal the number of hours. All right, so make sure when you represent the unknown, you're not saying x equal 27. You're saying x equal what you're trying to find. What am I trying to find? The number of hours. Okay, so I have the unknown. There's only one unknown here, number of hours. Now I'm going to set up the equation. Now you're going to set up the equation based on your own experiences dealing with these things. So what does that 27 represent that's in the problem?
Per hour.
That's per hour. So for every hour, you have to pay what? 27. So how do you think you would represent that information? 27x. Okay, good. So 27x. Now what else are you going to have to pay for? The part. So you're going to add what? $80. So that's kind of like a fixed fee, right? The $80 has nothing to do with the number of hours, correct? So regardless of how many hours it takes, you still have to pay what? $80. And this whole cost is going to be what? 404. So there's your equation. So 27x plus 80 equals $404. And you just solve for x. So what's the next step? Subtract 80. So 27x equal 324, is that right? Okay, then divide both sides by 27. So about how many hours is this going to take? 12? All right, 12 hours. All right, so then answer the question, you would say it will take about 12 hours. Okay. All right, so that was 16. All right, 18. Let's look at 18. Okay, 18, it says a professional carpet cleaning service charges $30 plus $22.50 per hour to come to your house. if your total bill is $119.25 before taxes, how many hours were you charged? It's kind of the same thing, right? So what are you going to let x equal?
Number of hours.
Number of hours. All right, how would you set up the equation?
25.
Yeah, so it's 25.50 per hour, because that's me 25.5x, and then what?
Plus 30 hours equals 119.
119.25? All right, so that's your equation. What's the next step?
Subtract 30.
Subtract 30. So 25.5x equal, what's that? 89.25. What's the next step? 22.5. So what's x? 3.5. All right. So you were charged for 3.5 hours? All right, so just write in a sentence. Don't just put 3.5. Say something like I just did, or the person cleaned the house for 3.5 hours, something like that. All right, now go to page, let's see. Okay. So all right, so we'll do the next one next class period. So I'm not going to give you this although I could, I can give you this. It's not due 1 week from today, but at least you can start 1 and 2, right?
Yeah.
And then 3. I was gonna do one like number 4, but I'll do one like number 4 next class period. So let me give you this. It's not due Tuesday. It's going to be due Thursday, a week from Thursday.